Welcome students to a new block of the online learning course Differential Equations with course code MAT 18R4031. This is the beginning of the block 4 with unit 1. Okay. So this is offered by Department of Mathematics, Kalasalingam Academy of Research and Education. So I will start a new topic in this block. In the previous block, that is in block 4, I had completed rigorous discussion on partial differential equations of first order and its solution techniques, mainly Clairaut's form. Okay, and also I have discussed the Pfaffian differential equations from obtained from PDEs. That was applicable only when your PDE was given in first order and sometimes also in linear first order. Okay, now I am moving to higher order PDEs, namely second order P. So let me write it here, second order PDEs. Okay, I'm sorry, do that. Second order PDEs. So in many practical problems in science and engineering, when the problem is formulated mathematically, it gives rise to partial differential equations, and as you know, it can often referred as PDE. Okay, in order to understand the physical behavior of the mathematical model, it is necessary to have some knowledge about mathematical character, properties, and solution of the governing PDE equations. Okay, an equation which involves several independent variables, usually denoted as x, y. Okay, this I will be considering only these two, but your function maybe contains more independent variables. But for this time buying and for simplicity, I will take only these two independent variables, and this independent variable governs z. Okay, and you will be given with some partial differential equations that you will be given with some relation uh, f with x, y, z, del z, del x, del z, del y. Okay, up to that it was first order, but if I further move del to z, del x, let me allow to write it here, del to z, del x, del y, and del to z, then eventually you can see that this is nothing, this is no more no longer it is first order, it is now of second order. Okay, for example, I will be writing this maybe in short, can also be written as x comma y comma z comma zx zy zxx. Okay, and zxy zyy also. Okay, so let me take a new page here. So I will give you some example of second order PDEs. So that is number one, this is nothing but u of t is equal to k of uxx plus uyy plus uzz. So this equation has a special name also, it's called 3D heat equation. Okay, or sometimes called three-dimensional diffusion equation. Here this u is the dependent variable, is function of both x and t, and these two are the independent variables. Let us take another example of second order PDE. So this is as uxx uyy uzz equal to 0. It also has a special name, it called Laplace equation. Okay, let me take some more. Okay, like utt equal to c square into uxx uyy uzz. Okay, this is nothing but three-dimensional wave equation, and this equation is also called 3D Laplace equation. 3D means there are three variables. I mean, u is a function of x comma y comma z. That's why I am referring the term 3D here. Okay, and there is a small correction I would like to say, that will be 3 u x comma y comma z and t. Okay, so let me erase it and write it again. Okay, this is x comma y comma z and t. Okay, so it depends on the what do I say, the coordinate of a particular point in three-dimensional geometry and time. Okay, so this is, as I said, is called a heat equation. So this all appears in physics or engineering or many other branches of science only. Okay, so that's why second order understanding of second order differential equations is very important. Okay, now before I go for the solution techniques of this second order differential equations and start it, I first want to classify second order PDE. So what do we mean by the classification of second order PDE? So let me give the heading as, okay, this is very important, classification of second order. Okay, so I will be considering where that in this case only two variables. Okay, two independent variables, u as a function of two variables. Okay, okay, then the general second order PDE can be written as, how we can write it as a into uxx plus b into x comma y plus c into u comma y plus d into u of x, e into u of y, let me write here also, plus finally f into u equal to g. Okay, here this capital A, B, C, D, E, F up to G are all functions of independent variables x and y. Okay, so this is the general form. This, let me just write it here, equation number 1. This equation number 1 gives the general form. Here it is, general form of second order PDE. Now inspired by the classification of second order quadratic equation. So what is that? Let me again write it. Now the second order quadratic equation in variable x and y can be written as capital A into x square b into xy plus c into y square plus d into x plus e into y plus f equal to g. Okay, here you consider a b c d e f g as constant only. Okay, but as we all know, this equation will be called elliptic according to the sign of this quantity known as discriminant. Okay, discriminant, and which is defined as b square minus 4 into AAC. We all know that this quadratic equation is said to be uh, elliptic when is less than 0, that is when it's okay. Let me name this quantity as capital D. Okay, and call this as discriminant, as you know, and we just compare the equation number 1, that is the general second order ODE, with this quadratic equation, and inspired by the classification of this second order quadratic equation in x and y, we will name the or we will classify the second order PDE also. Let me write it one by one. When D is negative, okay, then 1 will be called as elliptic. When D is 0, then 1 is parabolic, and when D is positive, then 1 is hyperbolic. So why this name? Okay, so that's, I just want to give you details why this name. Look at this equation. As I told you, this is a second order quadratic equation in x and y. So in two-dimensional geometry, this basically represents conics, right? Conics means it starts from ellipse, then parabola and hyperbola. Circle is also a special type of conics. It comes under the category of ellipse only, where your major axis and minor axis are same. So this part is from geometry. I don't want to go there. I just simply want to motivate you that this nomenclature of the second order PDE inspired by the classification of these equations, this second order equation, second order quadratic equation. Okay, as we all know from our coordinate geometry, that this equation represents a ellipse. Okay, an ellipse when the discriminant is less than 0. This represents a parabola when d equal to 0, and finally this represents a hyperbola when the discriminant is positive. So inspired from this example only, we are classifying PDEs. I hope this is clear to you right now. Okay, now let me show you some example of classification of PDE. So allow me some time to get a problem for you. In problem set, okay, I got it. So let us consider a problem as, okay, consider the PDE. Consider the second order PDE basically as write it here, u xx minus 2 sin x into u xy minus cos square x into uyy, not uy only, so let me undo. Okay, uy. Okay, this is equal to 0. Now I want to classify this second order PDE. So for that I have to compare this equation with equation number 1, that is here. This is, if you remember, so this is the equation number 1. So let me just underline it for your convenience. So this is equation number 1. So if I compare this problem with this equation number 1, then definitely I can write as, I can just writing your a is 1, e is minus 2 sin x, right? I think I missed something. Okay, I missed something in the problem. Let me rewrite the problem. Let me just complete the problem again. Nothing more. There is one extra term. So one extra term is that is cos square x into y uyy only, and with that there is another term cos x into uy. Okay, then let us again compare. This capital C is then nothing but minus cos square x. Okay, so I got my A, B and C, and this is enough to calculate the discriminant, since it will contain only A, B, C only. So as you can see here, okay, here that b square minus 4ac is the discriminant. Let us find this. Okay, let us take another color. Then the discriminant d, how do b square minus, okay, sorry, as we all know, this is nothing but equal to b square minus 4ac. Okay, so your b square is 4 into sin square x, that is 4 into a means 1 and c means, so that will be plus cos square x. Very easy, then you can take 4 common, 4 into sin square x plus cos square x, hence this is 4, and which is positive. So positive means this is hyperbolic, right? So I am writing, where should I write? I am writing here, therefore just take some other color, yellow maybe. So this color just represents the steps. Okay, so how many steps I have to follow, that just this color represents. Therefore 1 is hyperbolic. I hope it's absolutely clear to you. Now again, let us take another problem. Okay, let me change the color. Yeah, consider the PDE as the PDE is given in this form: uxx plus x into uyy equal to 0 whenever x is not equal to 0. So again, I wish to compare this PDE with the general equation. Let me show you again this equation number 1. So if I compare this, what I will get? I will get a equal to 1, b equal to 0 and c equal to x. So I don't need anything else, though all are zeros and d, e, f, g all are zero, but I don't need. I need to calculate the discriminant now. So let me take another color. The discriminant in this case is capital D equal to b square minus 4ac. So b is 0, 4 into a is 1, so minus 4x. So as you can see here, the sign of D will depend on whether x is positive or negative. So there are two types. If x is greater than 0, then D is negative and the given PDE is elliptic. Okay, let me take another color, green maybe. Again, if x is negative, then D is positive, right? And hence the PDE is hyperbolic in this case. So finally, as a whole, we can write, let me take the conclusion, the PDE is of mixed type. So basically this is the conclusion, mixed type, since it's neither elliptic or neither hyperbolic as a whole, rather it depends on the sign of the x. Okay, so these two cases you have to consider. Let me show you here, x greater than 0, and another one is written here, okay, here x less than 0. So according to these two cases, your answer will be there. So as a whole, you have to say that the PDE is of mixed type. Okay. So with that, I conclude today's lecture. Hope you enjoyed and try to follow the algorithm, or try to follow the steps while solving or while classifying second order differential equations. In the next video lecture, I will be starting the solution techniques for second order PDEs. Thank you, students. Let me stop here for today.